Okay, so today we are going to be handling the data, all right, according to our own schedule, be timeline. We have D for digital literacy. The next schedule or module is the application and operation. Then you have information management. So we are done with the first two. We are going to handle information management. This is very key. The world is driven by data. So I'm going to just go right straight into it. So the truth is that we are now living in a world of data. You don't have to accept it, but this is actually the truth. 90% of the data is generated in the last 2 years, so it's going to continue like that. Like, I mean, from history of man, 10% has been generated since beginning of data generation, like when people started writing stuff on the wall till recently. So what we are saying is that in just 2 years, the 90% of the data that have ever been generated by man was generated in this. Do you know why? Some people might be doubting this, but you know how many people that are obtaining smartphones, smart devices, the internet is becoming cheaper and faster. We move from edge to 2G, 3G. We are now with the fourth generation in Nigeria. By the way, I think MTN is trying to test the fifth generation, and the sixth generation is already in the labs. So in the next 10 years, we'll have the 6G network, which is going to be as fast as downloading 1 terabit per second. That's like a full movie in 3 seconds. So what is happening now is that the rate at which you consume data or transfer data has exponentially or harmonic, I don't know, as in it has actually increased very, very well. So some of you have one device today, tomorrow you might have three, different accounts. People are opening accounts as we speak and everything. So the volume of data that is generated, that's why data analysis now is becoming a thing. People are being paid to make sense of all the data that is being generated. So it is really, growing rapidly. In fact, more than 2.7 zettabyte. If you know what is zettabyte, you have tera, giga, it goes on and on and on. Like I can't, I think I did this in the week one. I told you how the information is measured in bits and in bytes and all that. So what we are talking about is that we might grow up to 180 zettabytes in 2025, right? So we are still mid-year. We need to verify this information. But it's true because I'll give you an example. There was no Netflix 3 years ago. Sorry, 5 years ago. Today you have YouTube. People are now, making money with it, which means this has given people access to even upload information. We are chatting every day using WhatsApp, using Messenger. We are tweeting and all that. Data, the rate at which data is generated. Now, I want you to look at the reason why we are here today is not to talk about the data, but the thing is the ink, the red ink there. Data analysis plays an integral role in today's data-driven world. Therefore, the ability to extract meaningful insight from vast amount of data, you see that those particular clause, like this particular clause that is, giving the red ink, it has become crucial for businesses to make informed decisions, optimize processes, and identify opportunities. Therefore, if you can do that, you're going to be paid for it. Simple. you know for instance, in oil and gas, you have different oil wells and everything. People, there's what they call upgrade. People are beginning to upgrade, like oil and gas. At least I'll talk about that one because somehow my discipline is petroleum engineering and I know what goes on there. So you have this well, the what they call legacy. I'm going to be teaching you new terms, like, so that whenever anybody says something like that, you not be like, what is it? So when you hear legacy, please, it's not like somebody that did something great and people are knowing about like Fela left a legacy. No. When you hear legacy in terms of information technology, in terms of operation and all that, legacy means old, please. So these are some of the things that you might start hearing. Okay. It means old. Okay. So when we talk about all those, we begin to look at you know, data being, pivotal to our, as written on this slide, processes, right? We need to optimize our processes. We need to make informed decisions about them and identify opportunities. That is why, in this world today, a lot of things, are driven by data. So in this course, this thing is actually we are going to start immediately. This is the intro part of it, to have an insight. Some of you might be programmers, but the idea of DAIPODS is to give you an overview about everything. So we cannot really do DAIPODS without touching data. It means we have not actually, because data is the center of it. In fact, the word IT is information technology, and that information is simply, data. So let's look at what is information and what is data. Okay, data is a collection of facts and statistics. Most of the time it's not organized, right? It comes without context. It can be quantifiable, but sometimes you cannot get a qualitative description of that data. An example, for instance, is number of website visitors. Okay, individual customer responses. Okay, product price. Yeah, these are three examples. But look at information. Now, when data is collected, it's actually data. Information does not just come, right? It's requirement gathering, intelligence gathering, data gathering that forms information. So, example, if you are looking at something that has context, right, and can be used to make decision, most of the time data is there. So when you gather data, right, that's what statisticians do. They use the data, okay, to try and make decisions. So, example, if you are looking at the other side, data is number of website visitors. In information, you are looking at website traffic changes, for instance. Is it growing? If I just looking at the number, staring at it, there is not sending any information. But if you were hitting 20,000, all of a sudden, you are now down to 5,000. The difference is information, because there is a context to it. In a simple term, you have analyzed it simply to show that there has been a decline. Simple. Okay, there's been a reduction. So okay, of course there are deeper analysis that we can do. So there are a lot of things, customer sentiment based on survey results. So you need to analyze the survey response before you cannot just gather the survey response that it gives you information. You need to write, okay, kind of look at it again. So let us go on, right? Now, information and data. If you look at it now, right? Without context, information is already processed. The other one cannot be utilized for by themselves, right? Um, Information, can be used to make decisions. That's the truth. But you have to combine the two, right? That's what this slide is showing. Can be composed of. Now, this is what we are going to do in this particular class. We're going to be looking at different data, the way it comes and everything, letters, numbers, characters, image, sound, and all that. So we are going to do that. Now, data, have a life cycle, and it comes from the source. Okay. The first place, the place of data is important in the discussion of data analysis and information management. So broadly, there are two places you can get information from. Number one is directly, and number two is indirectly. So if you are getting data directly from the source, you call it primary data. It's as simple as that. No much confusion. Okay. For instance, if I ask every one of you on this call, tell me your favorite food, I am asking you directly, right? But do you know that there could be a book on the participants of KodeCamp where this information will still be? If I go there and read that David likes, pounded yam, and Utibe likes beans and everything, it is not, even though I'm getting the same information, but it is no longer primary information. So I don't want you to cram it. I just want you to understand it, right? So I am getting exactly the same information. But for the fact that I didn't get it directly, somebody have gathered it already and dropped it in the database. So I am now referring to information. So I'm getting it indirectly, okay? So, for instance, in market research, okay, it can become, this is an example. There could be a lot of case studies, so we can't really do them. But if we use this example, we'll move on. If you're conducting market research, you can conduct it by yourself or hire a firm to do it for you. So when I say conduct by yourself, I didn't actually mean that you have to go to the field. But if you are responsible for gathering the information, for instance, I pay people to go on the street and get information for me today, that is primary because they are getting it on my behalf. So you can't refer to that particular one as secondary. Okay. So for the other side, secondary, conducted by someone else. When I mean someone else, it's not your resources that is motivating or inspiring the person to go and conduct the research. You're not the one that is funding it. You're not the one that is actually initiating it and all that. So it's none of your business. Okay. So I want you to differentiate the two because I could actually kind of sponsor you to get information from me. So let's go to sources. Okay. For primary data, online survey, for instance, using like Survey Monkey is an example. You have Google Docs, sorry, Google Form. There's equally Microsoft Form as well. So these are the three that I've used, right? And they are very good. Okay, they are very, very good, for specific reasons. So for secondary, you go to the internet, ChatGPT can give you information about all those kind of things. It's not you that got information you're referring to. And that's why sometimes when you're writing an article, people encourage you to reference the source that you got the information from, even if it's an image. This particular slide you are looking at is an example. You can see it is Drive Research that I got it from. I did not clean it up. Some people are used to when they get information, they will cover where it is, because this is going to be on YouTube, Drive Research, you come and see their slide. And I did not refer to them. So, by mentioning their name, somebody might be curious. So I'm driving traffic to them as well. So I am saying that this is not my information. Okay. I didn't get it directly through primary means. It's a secondary reference. So just take note of that. It is specific to your need. So you can design your own research method, so that of course you have to ask your hypothesis at the beginning of the research so that you know the problem you're trying to solve, the phenomenon you're trying to investigate, you kind of develop, this hypothesis for it and test it either to be true or false. All right. So you control the quality in terms of primary research. But the down part of it is that if you are ready, you understand, it will actually, require a lot of funding if you want to carry out. For instance, if I want to talk about poverty in Nigeria, it doesn't make any sense for me to start um, creating my own research method or trying to develop a project for that. That's a waste of time. I'll simply go to National Bureau of Statistics and get the information I want to get there. However, they get the information, I will refer to them. So, in case that information is wrong, you can indemnify yourself from that responsibility. So, let's moving on. This is, broadly, you can see what doctorate is where I got this information from, and I've actually referred it here. So you can go check them out. So primary source data, you can see other methods that we use is questionnaire. You can write questionnaire, whether it's online questionnaire or also you can get information from people. You can do schedules, right? Schedules is a kind of report that an organization kind of prepares. Sometimes it's a matter of nomenclature. You understand? So observations, of course, directly. You can just observe something and write a story about your observation. That is direct experience. Okay. You can equally carry out interviews and then you can go to the lab and perform empirical investigation by experimentation, right? So yeah, these are things that you do to get information. But when you come to secondary data, man, there are a lot. I can go to government information, government data, organizational declaration, office documents, statistical records, articles online. You have books, even journals, even magazines. You can get them from library. So now, to conclude on this before I move on, you can't say that there's a perfect data gathering technique. It depends on what you want to gather. For instance, if you want to study COVID-19, and you tell me that you're going to carry out an experiment to get information from people, the answer is a very big no. So you go to CDC, Center for Disease Control. That's where you get the information about what happened during the pandemic. So, sorry. So, hold on. So, you can get the information from there because that's the only, let me say, okay. So, having mentioned that, let's move on. So, well, I'm going to look at, different ways people go about their information because I remember the premises upon which you are building this particular module of the course is that when you are able to analyze data, you are important and you are relevant in today's world. How do you go about it? Number one, if you are using a primary pipeline, it means you are the one asking questions. Example, I want to know the literacy level between girls in a particular area and girls in that area. It is your curiosity. That's your question, right? And you want to find answer to that question. Okay. So you are the one that will design how you want to collect the data. So if you are checking area A versus area B, so you are going to say, okay, you don't want to go to area C because area C is not even within your own coverage, the population that you're talking about. I'm not using statistical term. So population is the entirety of what you want to study. But because it is impossible to cover the whole population, you do what we call sampling. Okay, that's what I'm trying to explain here. So the sampling is now that, okay, I'm going to go to A and B and collect because I need sample from A, I need sample from B because that's my hypothetical. So you don't do your data collection. Let's go to the third one, okay, before I come to the one in the middle. Secondary pipeline. Sometimes you want to know the impact of COVID, for instance, okay, on something, right? The first place you want to go to is, if it is in Nigeria, I want to go to NCDC, National Control for NC, National Commission for Disease Control, something like that. Or you go to CDC, Center for Disease Control, that's the UN, United Nations. So you're going to get the COVID information. From there, you're going to now form your hypothesis, right? You can see in this case, the data comes first. Then you start asking your question as, okay, what can I do to get information from here? You collect that information and then do your listing. But in some cases, right, it is not cast on stone. So sometimes you need to combine the primary data pipeline and the second data pipeline, and that's the one you have in the middle, right? So what happens is that somebody can, give you information and say, do you know that people in this particular area are usually brilliant? They do very well. So that question has been raised, okay? Now, what you need to do is you kind of use an existing data, right? And now form your hypothesis, okay? that will help you now collect the information that you need. Existing data in this particular case could be how many Nigerians are doing well abroad. You're not going to be studying every Nigerian that has ever traveled. So first of all, you may have to go to the embassy and if they have that kind of record. No, this is hypothetical case. Please don't take it seriously. So you go to the embassy. So the embassy first of all gives you data, right? You now ask your question. So people from a particular area, you now drill deeper and see if the hypothesis is true. In this case, you are now equally gathering information from yourself. You're not going to keep gathering information. So you have a primary data source, secondary data source. You are now kind of collating information as well from them, compiling it. Okay. At the end of the day, you can now probably visual. At the end of the day, all these things goes. What you see there as visualization is simply making the data tell a story in your mind. How do you visualize this information? When you visualize it, you can now make informed decision about it. Okay, so these are based on the source of data that you are using. Now let us talk about sampling. Right, we have talked about the sources of information and everything, but if we find a source, how do we even take information from that source? So that brings us to sampling. Right, sampling is important in terms of data analysis because there is no way, I've said it before, in statistics, the entity you are studying is called the population. If you want to study poor people in Nigeria, ladies and gentlemen, it is impossible for you to meet every poor man in Nigeria. That's why the world uses the terms like index, poverty index, human development index, blah, 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 index and everything. It's an approximation, okay? When they say this is a developing country with GDP of blah, 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 blah. See, there's no way you can actually get every single information from the population you want to study. That is what gives birth to what we call sampling. Okay, right now, let's talk about sampling. In sampling, there are two broad categories of sampling. I want you to note it today. You might be doing it, but you don't even know what you're doing. So I need to clear all those things today. So the first one is probability sampling, and the other one is non-probability sampling. Right? People have studied probability in school, probability of a head and a tail, and all those kind of things, where you roll a dice, you know, Now, there's what they call possibility of outcome. So that I'm going to use it to define what the difference between the probability sampling and non-probability sampling. Probability sampling, all the sampling methods, the members of a population, that you are sampling has a certain probability of being chosen. In non-probability sampling, there's nothing like that. Okay, you are going to see when I take the one after the other, right? So let us go to simple random sampling. Okay, it is simple, it's random, and it's probabilistic. Now, I enter a class, right? And I want to know how many of these people in this class can speak French. Okay, or I want to know, no, that's not a very good example. Let me say I want to know how yes, the class, there are 100 people, right? And I want to know how good they are in a particular course, maybe computer science or something. There's no way, I can ask them, you know, everybody to write the exam unless I am their teacher. But if I just want to sample the class, right, I can take a topic that the teacher just taught. Maybe I have information that the teacher taught a topic last week. I can bring that topic, you understand? And random, because I don't have time to set, I am not their teacher. I am not going to set exam for all of them because that's another way of gathering information, of testing the level of knowledge of students. This time around, I want to do it, randomly. Now, when you hear randomly, it means that if there are, example, 50 people in that class, and I just want to take 10 to ask them question around the computer science topic that they just did last week. What it means in essence that everybody in that class has a chance. That is, if you do the probability mathematics. It is the number you are going to take divided by the total. So I'm going to take 10 of them, and they are 50. It's going to be 10 over 50, which is 1 over 5. So every single individual in that class has a chance of being chosen, of 1 over 5. How do you have 1 over 5 chance of being chosen? That is the idea of probabilistic sampling. So even if I close my eye and just pick them, you understand? The people that I've picked, they are just lucky, right? If you are taking an exam, it means that probability I'm using is 100%. All of them will write the exam and pass. And submit their score. So I'm taking the whole this thing. But it is not in all cases. What if you are not, like I said, what if you are not their teacher? So you cannot cover the whole population. You have to take 10 people. Okay, let me ask you a question. Can you define a computer? What is the difference between input and output? Something like that. How these 10 people respond might give you an idea of the rest of the people in the class. That is this thing, random sampling. Let's go to the next one. The next one is stratified sampling, right? Stratified sampling is advanced form of random sampling. There is still probability there, but let me break it down. Strata, that stratified is gotten from the word strata. Strata, for instance, in rocks, at least I studied geology. What I know of strata is different rocks, that are layered upon each other, and they're having different characteristics. Okay, and they are distinctive. You can see if you are passing roads. Oh, my screen. All right, so in stratified, you're going to now divide the class into two, because in the population you now have 30 boys, sorry, 30 girls and 20 boys. So if I want to have 5 girls and 5 boys, I wouldn't use the first method, because I might end up getting, like, because the girls are more in population, I might end up getting like 7 girls and like 3 boys or something. So first of all, stratify them, divide them into two groups, and also, okay, from the girls, I'm going to take 5. So since the girls are 30 in number, the probability is 5 over 30, which is 1 over 6, right? For the boys, the probability is 5 over 20, which is 1 over 4. So you could see there's probability there, but the class has been stratified. Now I'll have a representation. You see, this thing I'm explaining it depends on the objective of the person carrying out. So you can see this objective, gender, is important. That's why I'm doing stratified. But if it is not, you can as well go with your random. So we're going to all right, so when you want to go to cluster is not really stratified. Cluster is dividing without really criteria. It's still dividing, but it's not with a criteria. For instance, I can divide in clusters of maybe, I would say, all the students should gather. Okay, I would see a line here. If you're on this side, go this side. I want to divide yourself into 5 equal clusters, and then I'll do random sampling from the cluster. Now, I am not defining that cluster. If I define it, it becomes stratified. If I say JS1 this side, JS2 this side, I am now stratifying it, because probably I want to have equal representation of JS1 and JS2. But if I just divide, these people go this side, these people go this side, right? So I'm just trying to create a mental image. There are more serious examples I could give, but this makes it simpler, you understand? So you could see when you finally divide them into clusters, now when you want to take your sample again, that word probability comes back again. So each of the member of that sample, of that population, has a chance of being chosen. Now, the last one is systematic sampling. Systematic sampling is where you devise a means of dividing the sample and probably selecting the part that you need. I think we do this a lot. For instance, if I come to a class, I can decide to give them numbers. Okay, I'll divide to give them numbers 1, 2, 3, 4, 5, 7, 8, 9, 10. That's the system. I say number 1 to 10 this way, number 20 to So number 11 to 20 this way, number 21 to 30 this way. Now see, I have used numbering, to kind of create, divide the class and everything. I can now take sampling and everything. So that's what is systematic. And equally use the idea of, okay, you take number. If I want to divide the class into three, I will start from the first person. You take number one, the next person will take number two, the next person will take number three, and I will now return to one. One, two, three, one, two, three, one, two, three, one, two, three. When I get to the end, I say all ones, all the people that have number ones this way, number two. You can see that's what they call systematic. You understand? You are creating a system, okay, a logical way of dividing the class into different groups. So now let us go to the non-probability sampling. This one, there's nothing like probability there. For instance, convenient method, the one that bloggers use, all these people that create content, they just go to the street and start asking people questions. Okay, it's random. They can go to the market. Okay, are you going to vote for? Who are you going to vote for? Donald Trump? Because all this kind of thing is random. Sorry, it's not random. It's convenience. You understand? Convenience. There's nothing. There's really no rule. You just go out there and start gathering information. So I don't need to talk about that. Quota is close to cluster. When you remove probability from cluster, you get quota. Quota system is like, for instance, we have geopolitical zones, right? You can't call it cluster because at the end of the day, there was what they call federal character. In all this grammar that our elites are using, federal character, there must be this person, there must be a minister from each of the states, blah, 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 blah. So you could see what is giving that particular opportunity is what we call quota. A quota is actually specialized, is actually reserved, for a certain entity that fits into a particular identity. So that's it. Snowball sampling is sampling for information that is difficult using any other means that you can mention here. I'll give you an example, right? If I want to probably let me say, for instance, if I want to study something like cultism in Nigeria, right? I'm going to use snowball method because I cannot go to the street on the market and start asking people, are you, how do you see confraternity and stuff like that? Okay. What I'm going to do is I'll choose, there's what I call snowball. Snowball is that you choose it's like a tree. You begin to drill down so that drill down with information. You have to be informed. It's an informed drilling down. It's not a random or it's not a convenient drilling down. So I'll go to, first of all, say I'll choose all Nigerian tertiary public institutions, right? I was okay, where is it prevalent? Of course, I don't want to mention some school's name here. Okay, can you hear me? I want to confirm that someone can hear me. I hope I'm audible enough. Can someone please talk? I need audio now, audio confirmation. Yes, I've seen. Okay, okay. All right. So now, if I'm studying confidence, so I'm likely to, because you have to make snowball now, you have to drill down. First of all, you can see by choosing tertiary institutions, you have eliminated, a lot of, unlikely sources. Now, among the tertiary institutions, they can actually say, if you go to this university, that's where they have their headquarters and everything. Now, not all universities will be on the list. I will not eliminate those that are not fitting there. Until probably I come to a particular university where they say, man, this is the headquarters of this kind of behavior. I now go in that place as okay, how many boys I can now probably they can decide to cover their faces. If CNN wants to get information about the Niger Delta, they have to go to the Niger Delta. They cannot stay. You see interviews like that on BBC where the people carry gun. They allow the people to enter their camp, cover their faces, and they are happy to share, the information with them. They say we are not happy. This one, this one, this one, this one, this one. Because they believe that is the. So people like CNN and BBC and everything, for me, I've seen it a lot. They go deep down. I'm sure some people have gone to interview, terrorist organizations and stuff like that, and they allow them in. That's what they call snowballing, because you cannot just be, high-handed in your information gathering and just gather information in here. So you have to snowball. If I'm talking about HIV and AIDS, probably I have to go to NACA, National Action Committee on AIDS, for instance. I will now go to some HMOs that deal on HIV and AIDS. See, I will keep drilling down, until I get maybe 30 sample of people that are suffering from that disease and how they are coping with it. I can now do my story. So that's what they call snowballing. Snowballing is like knowing the target and not doing random checking and stuff like that. Judgmental, judgmental is as good as convenience, but convenience is non-judgmental. So the convenience sampling that is judgmental is referred to as judgmental sampling. So before you ask people, for instance, as if I come now, I think I should focus on girls alone and be asking them. That's judgmental. You understand? Because from day one, you have actually determined the identity and the characteristics of the sample you want to take. So you have actually created it. Say, today I'm not going to be asking guys anything. You understand? If I want to ask about, for instance, politicians, say, I'm not going to ask people that are from where he is. So you are being judgmental about it. I'm not saying that this is negative. I'm just teaching sampling, brothers and sisters, because sometimes judgmental is good. For instance, if I want to talk about trading, you understand, I might just narrow down to Igbo people in Nigeria. You understand? So that's a good judgmental sample. So it's not like when I say judgment, I'm not talking about the kingdom of God, the second coming of Jesus Christ, and everything. So we are talking about sampling here. So I've covered it. Sampling methods, the probability and non-probability sampling. You need to understand these things. So let's move on. So in moving on, we're now going to look at how do data, we are now moving to the data now, the information gathering. Where did we come from and where are we going? Okay. So having talked about the gathering of information, how does this information even come to us? So I want to use this particular session to talk about the evolution of data capture technologies. You know where we are coming from and where we are and probably where we are headed. So data capture technology refers to the method and tools used to collect data from different sources and convert it into digital format. Now we're talking about these two formats, right? So if you're going to capture this information, you need to ask yourself, how are they captured, right? Some of you are going to be doing data analysis and you need to know, first of all, the device that captured that machine. Secondly, the format. Some of you are going to be dealing with YAML file. Some of you are going to be dealing with CSVs. Some of you are going to be dealing with a lot of stuff, Even as a programmer, you need to equally understand the for instance, if they ask you to build a site that's going to have QR code and everything, how do you go about it? You need to understand these things, right? UI UX, the design of the interface and stuff like that, you need to understand as well. These technologies have evolved from manual recording methods of the olden days to sophisticated automated systems, even up to the artificial intelligence level and Internet of Things and cloud. One thing about DAIPODS is that we try as much as possible to take the story from, make it very natural. So when you talk about you have done data, what is it? So we really go deep into getting this information and passing it across to you. So let's start. So the first thing you need to understand is that from the ancient time to around 19th century, everything has been manual. There was nothing like machines that time. I'm going to take them slide by slide so you understand what I'm trying to say. Then we move from manual to what we call mechanical capture. Okay. So you have a mental image of this slide so that even if they wake you up, you don't need to cram the thing, but understand how it works. Now, from mechanical capture from the 19th century to the early 20th century, we are talking about what? Electromechanical and optical technologies around 20th century. Now, we're talking about digital automated data capture from late 20s, of course, to the 21st century And now we have AI powered and real-time data capture this thing. So let's go to them one after the other. So we have manual recording from the ancient time to the 19th century. Guys, we used to write, human beings like us used to write on the wall. You can't even call it wall. Yeah, wall of the caves, wall of on the houses, mud houses, and everything. That's how people represented information. For instance, the italics that 1111, they now cross it over and stuff like that. There are a lot of ways people use. I'm showing you example on this slide, okay? Like a plate that people used to this thing you're seeing here on the slide, it means something. As far as those people are concerned, this might be the way they counted their days in the calendar. Of course, there was no calendar there, and they've not studied rotation and revolution of whether the sun around the earth around the sun and rotation of the moon around the earth and all that. So number one, clay tablets, papyrus scroll. You know that in the olden days they have this ink that they used to, of course, people know if you are following the story of the ancient times, you know that what they call scroll. That scroll is actually what led to what we call telegraphy, cryptography, calligraphy. Sorry, that's what I was looking for. Calligraphy. That's what led to writing, and there was the development of the scroll. Um, you have the stylus, and then now we can now write. When we are listening, you can now write, take notes and stuff like that. So that was how the idea of manual process. Okay, we equally use it for bookkeeping. The olden days accountants actually wrote, using hands and stuff like they would draw lines, debit and credit and all that. So at some point, right, people were like, can't machine do this thing that our hand used to do? You can see how gradually the the mechanical, of course, the typewriter came into the place. Okay. Now you have printing press, and then you have things like Morse code. Morse code is enabling coded communication over a long distance. That is the first way of communicating. Morse code, look at Morse code where you see hello world, okay, down in this thing. You see people pressing this, you see the Morse code legend there. The one that you see that is dots and the one that you see that is dash. So it's simple words that you use. Probably you can send coordinates of where to bomb, so that your enemy, even if they intercept the signal, they will not understand. So this is what they call code. So when you say it means it's A. That dot means you touch it once. That dash means you hold it. Touch it, as in press it down and hold it. So you could see, when you understand Morse code, if somebody sends you code, you'll be able to put the letters together and they will form words, and then the words will form sentence. So that's what Morse code does. Okay. While this method were effective for their time, they were very, very slow and prone to human error and difficult to scale. You cannot scale some of these things now. I think the best that have happened in this era is the printing press, right? So, having said that, let's move to the next one. Let's go to the mechanical capture. You start having things like punch cards. So people built, of course, with the idea of abacus and stuff like that, differential machines, and you have punch cards. Okay. And around this era, the idea of photography, came into being. So what is photography? I think I have actually explained it, when I talked about observatory and all that, but I'm not going to go into that. But what is important here is that photography came in around the period of these mechanical devices. So the Industrial Revolution led to the development of mechanical capture technology, which improved the accuracy and efficiency. Number one is punch card, 1904 to 1804 to the 1890s. It is, used first in textile industry when people were building styles on rug. So where it is like 1 and 0. That's the idea of that's where the idea of 1 and 0 was created for the first time. So there's a way of reading information, and the scorecard has to be stored sequential. If you miss one sequence, you have lost the information there. So it is perforated, and the way it is perforated is sending a definitive information across. Number two is what we have typewriters, right? Yes, of course, it's a mechanical. You don't need to plug typewriter to light to electricity. So they kind of carved out the capital letters, small letter. There are mechanisms where you can raise it so that there's what they call ribbon. The carbon ribbon is something like carbon copy, so that it will print the ink in the ribbon. There's what dry ink in the ribbon on the paper. Of course, I don't know whether people have seen typewriter before or not. So photography is part of data capture, so we have to cover it, because today photography is one of the most important category of data. Photos and videos is what we are, all the viral stories and everything. Either it's captured in photo or it's captured in. So we're just, when did this thing start? In the late 1980s, right? Used to archive documented information. Okay. So what is bringing the next one? Okay. Why do we have to move from here? You look at that inscription that I say these methods introduce automation. Fine, it reduced the reliance on manual entry, but still lacked real-time data processing. So that is the problem. Man continues to solve problem. Let's go to the next one. Now we move to what we call electromechanics. See, maybe electricity enters. You are talking about exchange of electrons and stuff like that. Remember, I defined the first generation of electronic computers and the one that use vacuum tubes, the ENIACs and stuff like that. Not because there weren't mechanical devices before them, but for the fact that they started using this idea of one and zero, off and on and everything. So when you define computer today, your definition will start with is an electronic device. You're not going to say is a mechanical device. So let's go to it. Now you have barcode. Barcode scanner gives information as well. Invented by Noah Woodland and Bernard Silva in 1984. Okay, universal product code, like it's just like something that we have agreed that numbers can be coded. Okay, I want to show you something. Look at this Morse code, right? Imagine that J. Okay, imagine S. Okay, imagine A. So if you have A, J, S, now those dots and lines you are seeing, okay, if I kind of continue them, like put my finger there and draw the ink down and draw a line according to width of this thing, that will give you an idea of course, people have seen barcode before. Some lines are tiny, some of them are, have thickness and everything. So I just want to use this Morse code, just imagine, right? If I place my finger on it and then draw them down, like I kind of continue those dots. So what it means is that you can use them to represent information. So let me go back here. Magnetic stripe technology. If you look at your bank card, whether it is credit, whether it's debit card, there's a stripe down there. That stripe is magnetic, okay, and it's developed for banking credit system. So you need to have, some of those things. When you put it in ATM, it needs to read the information. So you can see from barcode, you can see that barcode there. You can see what I'm talking about. Each barcode, the lines represent a series of numbers. So what the universal product code is, if you do a new product for your company, they will assign it a universal code. So let me explain to you what that helps us to do today. If you go to supermarket, you are buying something, you see them scanning something, bam, bam, bam. What they are scanning is actually, because the universal code, there will be no two products in that whole supermarket that have the same barcode. So when they scan your own, they've already put the price of that particular number, digit that you are scanning. So when they scan it, it will just add to cart and add to your distance. So that's the technology behind that. So they need to scan what you bought, because it has what we call what? Universal Product what code, UPC. So magnetic stripe has a coded information. Your own magnetic stripe in your own ATM card cannot be the same with Lawrence's own. And that is how information are stored as well. Then we have what we call what optical character recognition, OCR. This one is the one is even very, very, very key today. When you use photography to capture an image, optical character means it uses the light, okay, the what we call contrast to extract text from an image. That's what we call optical character recognition. So if you snap a picture of a note and send that note to me as a picture, all I need to do is go to any online source or something. I'll use OCR. It's okay. I'll snap the picture and send it. The OCR will go into the listing image and try to extract the text, because what I want is the written text, not the picture. So that's what we refer to as optical is a way of equally capturing information and capturing data. Then QR code, everybody use QR code, of course. See, QR code did not start on its own. QR code is like an advanced barcode, right? You need to go and look at the story. The person that invented QR code is actually a bunch of ones and zeros and trying to get a particular combination of information. So QR code came in 1994, invented by Wave, a Toyota subsidiary. Improves upon barcodes. Yes, I mentioned it, to enable more data storage and multiple angle scanning. Yeah, because for barcode you must face it the way it is. Modern application of all this is like mobile pay. Of course, I don't need to talk about this. We are now in our own generation. So for me to define this thing means probably not. But let's go to the next one. We now have what we call digital automated data capture from 20 from the 20th century to the 21st century. You now have your RFID. You'll be hearing RFID. RFID simply means radio frequency identification. Some of you that are working in hotels or probably access denied, all those cards, they are RFID cards, right? Meaning that there's a radio frequency that they are transferring to the door that will open it. Yeah, it's a data capture machine, because the door will have a sensor that will capture that information, right? So you have biometric. Biometric has to do with human bio, right? And information metric. So fingerprints, facial recognition, iris scanner, voice authentication, these are biometric method of data capturing. Usually they use it for security and kind of protecting people's information and all that. Then we have smart cards. Smart card, you use it for our SIM cards. If you look at your ATM as well, you see the smart chip there, right? That chip is the most important thing, and that's why they keep cutting it. You see, you have standard, you have micro, and you have nano. Look at it there in the second line. Okay, so what people are doing now, they are reducing the space to occupy, because at the end of the day, those who space, it is the nano size that is important. That's where the smart chip is. So that particular gold like plated something in your credit card has some information and can only be captured with a POS machine or something like that. Okay, so let's move on. Document scanning and digital imaging. This one using your scanner, right? Scanner is now a thing. You just need to. In fact, there are some mobile apps now that can even scan as well. So it's kind of trying to capture and even store it in other file format like PDF and all that. Now we have mentioned QR code before, but we are going to mention it again. QR codes for digital transaction. Up to today, that's what we are using. I don't need to talk about QR code. You use QR code for WhatsApp, you use QR code for many, many things, you understand? So if time permits, QR code is a topic on its own. So let's just move ahead. All right. The final one I'm going to talk about is what we call NFC. This is going to be the latest tapping. When you tap, information is actually exchanged. You don't need to put it in POS, just tap. Okay. Somebody might be asking what's different between this one and RFID, because if I go to my hotel room, I will call it tap. Guys, RFID is not near field communication. even though they still use, a level of frequency for transmission of their information. Please let me mention it here for RFID, right? It is one way, the door, okay, has a sensor that receives. The card, sends the RFID signal. Okay. But when you come to near field communication, both devices are active. So they're not called active and passive. I'm going to define it here. It's a short range wireless communication technology. This is going to revolutionize things, right? That enables the exchange of data between devices over a distance of, you can see, tapping 4 cm. It's based on radio frequency. Like I said, there's already an RFID, but this is a special one. Okay. And it's primarily used for smartphone payment system, ID and ID verification and access control. Yes. How it was, NFC operates in the principle of electromagnetic induction between two loop antennas. It works in two modes. Okay, you have the passive and then you have the active. So the active is the one that is going to be transmitting the signal, while the passive is the one that is going to be what, um receiving the signal. Okay, so the active, both device, right? In the active, both devices generate their own RFID field to exchange data. That's the difference between that and the RFID. In the second one, passive mode, only one device generates the RFID, while the other is just for communication. You can see how the whole thing. I'm not going to bore you with all these stories. Okay. Early for the earliest time to 1980s, you introduced the RFID 2022. 2002, NFC was jointly developed by Sony and Philips. NFC forum established to analyze technology. That was in 2004. 2006, the first NFC enabled phone was launched. 2010, all the 2010s, integration into Android and stuff like that. Right now, 2020 to now, use widely contactless payments and transport. So that's how it has evolved. So having talked about data capture machine, let us look at the last one, AI and real-time data capture from 2020, 21st century till now. Internet of Things, sensors now capture data. So when you put sensor in your car, it will tell you that the tire is not well pressured. You need to go and pump your tire. Your cars, you have everything. So that is exactly where we are today, and that's where we are going. So you might think about some places this thing might help, solve their problems. So now data capture technologies, right? I think you even build your own app. You can decide to say, okay, authentication is going to be. That's why we're having two factors now and all that. So we have artificial intelligence, machine learning, of course, OCR, facial recognition. The one that is ready now is voice to speech and speech to text. Sorry, voice to text and text to speech. Okay, so that's one of the technologies that is ready now. So you see blockchain there. This is not a class for blockchain. We might not have enough time to talk about them. Then you now have your edge computing. Okay, so real-world applications, business and retail, healthcare. In fact, you can apply all these things in every business. I don't think there's a special, but these are top businesses you can apply these things for. For business, retail, POS, for healthcare, electronic health record, I talked about it. Finance and banking, manufacturing, logistics, government as well. So these are the areas that you can, talk. So future trends. Everybody get ready. Like I said, I'm going to tell you where you are coming from, where you are, and what you should be looking out for. So AI and computer vision integration is something is a field that's still relatively strange to people. Um, you need to pay attention to the 5G story, okay, when it's going to be released, because people are beginning to actually feel the effects. Some people are losing their jobs. So why we're saying this is so that you don't be among those that will be struggling to survive, you know. So a brain computer interface, this one Elon Musk, so I'm not going to talk about it. I'm not even comfortable with that as well. So but that's fine. Quantum computing still in the works. Example of expansion of QR codes applications. So summary, this is where I'm going to draw the curtain today. When it comes this, okay, let me touch this other one. So summary, data content technology has advanced significantly from manual data recording to AI-powered and real-time intelligence system. The introduction of barcodes, QR code, RFID, biometric IT sensors has revolutionized how businesses and governments collect and utilize data. Yeah, truth, facts. As technologies evolve, the future will see greater integration of AI, blockchain, uh, blockchain, technology, uh, edge computing, and all that. Okay, so however, privacy concerns and ethical considerations must be addressed to ensure responsible use of this technology. Responsible use of technology is referred to as the term digital literacy. No, yeah, digital literacy. Digital literacy. Okay, so let me just go into this so that I don't come back talking about it again in this class. So if you gather this information, whether from here or here, the next thing we are talking about, what is the nature of gathered information? We're no longer talking about the source or the category. So there are two, you can have structured data and unstructured data. Okay. So let me just go to this. Yeah, this slide shows it. So for structured data, most of them can be displayed in a table. Okay. Unstructured data cannot really be displayed in a table. For instance, different videos, you can't, okay, put the pictures of the movie in rows and column. So the other thing is that you're going to be looking at number strings and some of the native characters. I'm going to talk about it very soon. The other one, no, not really numbers. You're going to be looking at images, audio, video, word processing, and sorry, word processing files, email, and spreadsheets. So estimated 20% of enterprise, have this structured data, right? But in the real world, you are going to be dealing with more with unstructured data. That's where having 80%, of your enterprise is actually unstructured. So you need to pay attention to the unstructured data. Structured requires less storage. Of course, when you're storing common numbers and everything, it requires less storage. The other one will require more storage. We're talking about videos and audio and stuff like that. It is easy to move. The other one, more difficult to manage and protect with legacy solutions. Remember, I mentioned something about legacy. That's one thing you need to take home. So, in between structured and unstructured, I say restructured. So, let's not take this thing. I'm taking this information from Monkey Learn, right? You can see their logo there. So, for semi unstructured data, they are loosely organized, categorized using meta tag. Okay. Meta is actually an identifier. For instance, I say meta information. If you produce like 10,000 computers, right? And out of 10,000 of them, they might be shipping 50 to Africa. Do you know why? the materials that are used might not be, even though the system might be looking the same, but the material that are used for the ones that are coming from Africa might be slightly different from the ones. So, they will they'll give it a specific label. That is metadata. For instance, how many inches? Okay, what is the makeup of the Dell? How many gig does it have? Sorry, for the makeup of the computer, whether it's Dell or HP or Toshiba. Sorry about the slip of tongue. So you have all these things, So when you buy a system, there's a better data that came with the system. So other things are variable. For instance, the secondary memory, which is the storage device. So now we have a scenario whereby things are not really exactly unstructured, but they are semi-unstructured in such a way that, for instance, email, and then when you open your email, you see that the email page itself is looking like a table. I know you can download it. So that's the structured information. But you want to get information on each email, that's the body of the mail, it's not possible. So you can see somehow there is a structured part of email, but somehow there's an unstructured part of it. Today I might just send a long email. Another I might just send short one. What would you make of um um what insight can you drive from such data? So you can see that there are some of this thing that you have to like combine. So today we're going to be talking about categorization of data, right? So when you're obtaining this information, I've talked about structure. Structure is the way they are arranged, either in a video or in a table and everything. Now I'm going to be talking about the types, okay? So generally, okay, because we are still dealing with information management, you need to understand information before we go and start managing them. You divide this thing into two, right? Categorical and numerical. Categorical is divided into nominal and ordinal, where numerical is divided into interval and ratio. Um, I'm going to kind of break it down so that it wouldn't be confusing. First of all, when they say categorical, it means something that can become an identifier. Numerical will give you a number of values, right? So let's go to categorical. You can categorize me with my name. That's one of the easiest category. When you say Lawrence Auton, so that's a category. Okay, that's what we call nominal. Nominal is coming from nomenclature, like naming. Okay, norm. So nominal means you have a particular identifier that is unique to that entity that are giving that identity. For instance, if we are 100 in, let me say, in my class, all of us in that class will definitely have first name, the middle name, and the surname. It is going to be impossible for all these things to rhyme from different family that did not know you. So what happens is that the nominal is used for those identifiers. Okay. The ordinal is like the nominal. So nominal example is Nigeria. Nigeria is a country, is an identifier. Okay. If you say Jamaica, if you say America, they are all nominal. If you say Akwa Ibom state is nominal. If you say Eket, Eket is also nominal. But when you go into ordinal, you are still doing some identity, but you have added some form of measurement, not fully, because when we talk about measurement, you're going to move over to the numerical that you see on the screen. But let me go back to ordinal. You see an identifier. For instance, I can come to the class and say, please, I need short people. You see, it is still nominal categorization to it, right? Categorization that is based on, you can now probably in your head talk about height. There are some people that are short, there are some people that are middle, and there are some people that are high. These are nominal, okay? Let me use the example of the country. I told you that Nigeria is, okay, a developing country. If somebody decides to say, okay, there are developed, developing, and underdeveloped, that is actually ordinal because you have some form of graduation. from underdeveloped, developing, developed, and well developed. You can see that there's a way. Another one example I can give is I strongly disagree, I disagree, I am neutral, I strongly agree, and I strongly disagree. You could see that with all this, okay, you have put some kind of categorization to the whole conversation. Let us go to the numerical. Very interesting. Numerical is divided into two: interval and ratio. Interval is what we call integer, whole number. You cannot divide. For instance, if there are some information that you cannot have fraction. For instance, a human being or population, you cannot say population is, let me say, 5,000 and a half. There is, you cannot label a human being have 0.5. And since you cannot label a human being 0.5, all you need to do is to kind of give them, because you do a population count, okay, is what you use to um do that kind of nominal, sorry, numerical. So you cannot count human beings and be doing fraction. But if I'm talking about height, like I have 2.5 meter, yes, there could be fractions. Okay, there are certain things that, this ratio. There are other terms we are going to be seeing. Okay, as a programmer, you might hear something like float. Okay, because I'm going to break all these things down now. If you have something like float, you are referring to as ratio, actually. If you have something like scale, you are referring to ratio. What other terms is used? Scale, ratio, real number. Yeah. If you have something like real number, some these are different nomenclatures that are used for the same thing. Ratio, real number, scale, float. It means that something can actually be represented in fractions. So let's talk about, because I don't want you to just cram this in other schools of thoughts. Okay, you will now see that these people have their own categorization, but see, don't get confused. These things are almost the same thing, right? If you look at the first one, I just deliberately added it on top. You see, you clearly see that it is the same categorical and numerical. Fine. You now use ordinal and nominal, fine. But in this case now, you're going to see, instead of interval, see discrete and continuous. Yes, continuous is the other name I was looking for. So continuous, ratio, scale, continuous, ratio, scale, what is that last one? So float, yes, float. Anything that has decimal, so that's the difference between the first diagram and second diagram. Another difference you're going to notice is that under nominals, they decide to go further. You have dichotomous and polychotomous. Simple. Dichotomous is something that has two values. Polychotomous is something that has more than two values. It's as simple as that. So you see examples there and all that, but I want you to just understand it rather than just probably cram it. So this is from thought space learning. You can see the data type. You can see numeric and non-numeric. So they'll get confused. It is categorical and non-categorical. Okay. So you can see categorical and numeric. Instead of using categorical here, they're calling it non-numeric and then numeric. So under numeric, you can see distinct and continuous. So it is actually, conforming to this one. So what I'm showing you is something that will not confuse you, in case you see, yeah, primary data, secondary data collected by some. You see, all these things I mentioned, please, people will come up with different kinds of this thing. Never you get confused. Just okay, this is the way the person understands it. You see the same thing. When you come to non-numeric, you see like color, name of animal, brass, name of a person. All those things are, but they did not divide this their own into what? Um Nominal and ordinal. So that's different. But you can see here discrete. So I think this is just more like an example. They not just breaking down. This is another type. I just gathered a lot of them. If you look at this, I'm not going to explain this, but I want you to look at this and say, okay. These are what is what they mean. You understand? You could see. It's making sense now with all the explanation I've given. Is there another one? It's good. Java. Okay, let me add something here. You have what we call primitive and non-primitive, right? Okay. Now let me talk about primitive and non-primitive because these are the terms you might hear when you are, kind of doing programming and everything. Primitive, for instance, if you are running a Java program, right? You are kind of typing Python and stuff like that. There are data, right, in those Python that are original to Python. For instance, if you are doing a whole number, integer, float, and everything. But when you have something like an array is no longer primitive. It's no longer intrinsic. Array is, you can have an array of 3 by 3. You can have a class if you classify stuff, different method, interface, object, strings. Okay, these are non-primitive because they are not original with the runtime. Or there's what they call runtime. You can see, I mentioned runtime in the second this thing when we're talking about platform as a service where they provide you runtime. So the runtime naturally comes, so you can, declare a variable and all that. Natural. A is equals to this, B is equal. You don't need to. But when you are dealing with this, it's not primitive to that particular. Um, I'm not really here to teach you programming, but I think I don't want to take this too serious and start confusing you guys. Please, what I just want you to know that there's what they call primitive, that it is intrinsic in the programming language's runtime that you are using, and then there are ones that are derived. They are not just like derived and basic. So Python, you can see Python, some of those categorical non-primitive, you can see dictionary is one of the non-primitive sets and sequence, but Boolean and numeric need to be the same. But under numeric, you can see now they are talking about integer, and I'm talking about floats. You remember I say float is continuous and all that. So for sequence type, you have strings here and tuple, and then you have this. You can see the company that came up with this. Please, I'm just showing you different thoughts so that you have, if you be very well informed, nobody can confuse you. When you look at all this, is okay. This is what this one means and all that. C++, they have their user defined. User defined is like what you could refer to as it's not intrinsic, okay? And then there's one that is built in. Built in is intrinsic, which is primitive. The first one here is non-primitive. Second one here is primitive. Then the derived also is non-primitive as well. C++ simple. That's how it is done. So there are other school of thoughts, right? So we're going to talk about database today. Database is not storage. I just want to talk about database. Okay, it's not storage. Let me stretch my time a bit. I've taken information from the other meeting. So, database is actually information that is kind of queried and is alive. That's why it's called database. For instance, the bank database will be waiting for you to key in your admin password and blah, blah, blah. You log into your account, you withdraw it. How withdraw is that you are calling your accounts off from the data that is stored. And you are querying means seeking for information, editing information, deleting information, and like, so when you get all those things, and that's why today a transaction is without database, there will be no transaction. So no matter where all this information are gathered, whether structured or unstructured or semi-structured and everything is going to enter a database. It's as simple as that. That's what I'm trying to say. Example is Oracle. You have Amazon Relational Database, Microsoft Server, Postgres, MySQL, MariaDB database. So let's go into it a bit. Now, before we go into Excel, this is the last part of it. Then next we go into Excel. Okay, let us just look at this, right? Database is made up of two things. There's what they call field and there's what they call records. Okay. So let me break it down. If on this call I want to get information from all of us, I can drop a form. And in that form, I'm going to have first name, last name, phone number, first name, last name, phone number, sex, state of origin, something like that. Okay. You see, that first name last name, phone number, email, they are referred to as fields. Please note this thing is very, very important. They are referred to as fields. Okay. So, meaning that every one of you on the call will receive information, and that information is going to be indicating the field that you need to put value into. So, when I get my own form, I will see like 4 fields: first name, last name, phone number, and email. So, my first name is Lawrence. So, when I'm typing Lawrence, what I am giving is I'm giving that field a value. So, it's called field value. So phone number 080 something 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 like when I fill it now, when I finish filling my own, there will be a submit button. If I click on submit button, what I am submitting is a record, because a record is a collection of the values that I have supplied based on the field that is being asked for from me. So in this case, there are 4 fields. I've added my value. That is how 1 million people will fill the same thing and submit. When 1 million people fill the same thing and submit, it will now create a database of 1 million people with 4 fields and 1 million records. That's what this particular slide is talking about. So you could see the field names here are employee ID, first name, last name, title, date of birth, and address ID, right? A record now, you can see how a record now, somebody filling out all these things and submitting, have submitted a record. So the database has a record. Now the last part of it is the field value. Field value is what we are actually supplying to there. So in database, you have relational and non-relational database, right? Relational database is where the fields in the database are related, and the way it is arranged for what, for it to be easily queried. Database is all about querying. Okay, so I'll give you an example here with a relational database. The table you see on the left is the main table. Okay, that is the transaction table. It has transaction ID, customer ID, product ID, and purchase ID. Yeah. The most important thing here is the transaction, because it's keeping record of all the transactions. But guess what? If we are going to query that database and I have like 20 million records, it's going to be very difficult for me, right, to be querying that particular database. So there's a need to create smaller databases that will link, that's relational, that will relate to the main table in such a way that if I want to get information, I can get it from that second table. And then, of course, if I change the thing in the second table, it will update. Now, assuming the watermelon is now foreign and local, so I'll have to create another product ID in the second table. You understand? So that people that are coming will now know that there's a new type of watermelon. It will update. So that's how that product table is related to a transaction table. Also, we have customers that are coming for these things. Okay. So we might have to create another table for customers. If I add a new customer in that table, I don't have to go to the main table and start adding all these things. Or if the customer changes location, okay, or changes first name, or maybe removes their MD and it has to change, all you need to do is come to the customer table. You don't go to the main table and start searching for all the places where that customer, where that company changed their MD. You don't start replacing them. No. Once you do it in this smaller table, it will update in the bigger table. And you can see that's what we call relational database. But the problem with relational database is what I'm showing you here. Sometimes the information grows and grows and keep creating small things. At some point, it is going to have a problem of optimization. With the time, you are going to get the answer, but it might take a while because there are a lot of relations here. They are what they call relation is referred to as data model. We are going to come to that. They are what they call data model. You understand? So so at this point, you can now go to what? No SQL. No SQL is okay. SQL, first of all, is structured query language, which is used for what? Relational databases. No SQL is no non-structured query language. So the query language is actually the language that you use to kind of get information from data, do all the crawl. Crawl means create, read, update, and delete. Crawl. That's acronym for how you can interact with some of these technologies. So you have these are some of the what it just means is that I think I'll go to the next slide. The non-relational database, you can have example key value, you have documents, you have graphs in memory, and you have search. So to define it now, I'm going to use this. This is where I'm going to kind of summarize the relation. Now, when you start your small business, you're selling this thing, your tables are always very simple. You give, but at some point you have more customers, at some point some people will take credit, some point. So at some point, the data you're going to need, you might have to be creating small information. It's coming from the church and everything. At the end of the day, you're going to get confused. So what non-relational database has done is to solve that problem with a key. There's what they call schema. You see, and you notice some of these things I'm talking about. There's what they call data schema, right? Data schema is difficult to unite. This simple example I'm giving you now is what we refer to as data schema. You started your restaurant, right? People are coming, you have three food in the menu, right? They just come, take those three food, eat, pay you, and go. Guys, at some point, you are going to add. First of all, you're going to improve on the menu. You're not going to start with four and end with four. We have five additional, right? People are going to come and be doing takeaway, another information. Another person will say, okay, let me pay credits, another information. Another person will say, okay, combine. They don't used to combine soup before. Before you know it, there is a kind of complexity in that your simple business you started, right? Sometimes that complexity is what we refer to as changing the structure of the information. Okay, the structure of the information is no longer very simple, it becomes complicated. Now, when it becomes complicated, that particular structure is what we call schema. So when the schema is not the same, okay, it is called schemaless. So in schemaless information, I'm going to show you now in the next slide. So what this slide is showing is that relational data, that first part, top left, is showing that relational data is consistency, right? But it is hard to scale and it is resource intensive. What it means by resource intensive that this table I showed you, this table I showed you is going to consume a lot of computing power for you to get a query algorithm that will run through all these things. So that's what it means. So now, how do we solve this problem? Instead of scaling vertically, that's what you are now seeing on the top right hand side here. You now scale horizontally. Okay, that means I'll have a key and I have a value. Example you showed in the bottom left. Okay, the key is there. All right, it's like a code. You don't need, of course, the computer is fast enough. Okay, now you see the value there. Number one, MacBook Pro 13. Price is this and blah blah blah. The other one is USB or microphone. USB microphone, the schema of that first one and second one can never be the same. The USB microphone will not have how many gig RAM or this is not. Not talk of hand sanitizer. Hand sanitizer have a different kind of this, maybe chemical component. And so, but the truth is that companies, supermarkets, and everything will not say, okay, let me just limit to just one product. Okay, so what we are going to do now is to partition them so that when something of this particular nature, I'll just throw them into one database. And that's how I can manage. I cannot put all of them in the same database. So let me just give you an example here. You have a key, you have a hash. So the key, you can see the key space. Okay. In server one, anything that is between 0 and 25 will go into server one. I don't need to put them inside one server. That's what this thing simply means. So if I have 23, if you see 23 will be okay. Let's start from the first one. 23 will be in server one. The second one that has 87 micro USB, from that example I give you, will be in server what 4. You see, to retrieve information from this database is going to be simpler because they've been distributed across what we call key space. Okay, 23 will be in server one, and 100 is likely to be in server 4 as well. So this is how some of these things is done. So schemaless, this is an example of schemaless, just to demonstrate what schemaless means. You can see that the only thing common in all these things is name. After the name, when you go down, you start seeing differences. The first one has price. The second one has price by the one on the left, sorry, on the right hand side. So two of them, the first two lines are okay. But look at the third line. This one is having description, laptop. The other one is having discount. Now, this one does not have category. Why this one has category? Survivor. Are you seeing it? Hand sanitizer cannot be in the same scheme with what? Laptop. Microphone USB, you can see you're now having the price in euro and the price in USD. This is another thing. You can see what this thing is just demonstrating that there is no way these four items can be comfortably fitted in the same table. So there's no way they can fit it in the same table. So that's what they call schema, right? So you just understand it, don't cram it. Understanding this is perfect. So, ladies and gentlemen, I think this is where I'm going to draw the curtain for today. Next time I'm going to be talking about data analysis. Okay, we're going to be talking about data. We're going to start with data analysis life cycle, where we are now going to go through all of them and finally start our Excel. Yeah. So at this point, I think I'll stop sharing. Thanks for joining the class. Those that probably joined late, you should refer to the YouTube channel and get the class from the beginning. All right. Thank you very much. I'm going to stop recording now.